In this video, we'll be looking at the surface area and volume of cones. Now, some cones you've seen before are part of a funnel. The little orange cones you see that tell you not to go certain places. And ice cream cones are all examples of cones you've seen before. So there are some parts of a cone that are very important. First off, of course, you have the base, which is a circle. And in that circle, you have a radius. The radius forms an angle, a 90-degree angle with the height of the cone. The height is that distance that goes straight up and down from the vertex of the cone to the base. And finally, you have the slant height, which goes down the side of a cone. Now, this is very important that you notice that the height, the radius, and the slant height form a right triangle. So if ever you're given the height and the radius, you can figure out the slant height, or if you're given the slant height and the radius, you can figure out the height. So that's important that you notice that right triangle within a cone. All right, so here's the formulas for the lateral area, surface area, and volume of a cone. The lateral area of a cone is represented by pi times the radius times the slant height. Remember, slant height is represented by L. The total surface area is represented by pi r L, so that's the lateral area, plus pi r squared, which would be the area of the base. Another formula that does not show up on your chart, but I think might be easier to use sometimes, is pi r parentheses slant height plus radius. And finally, the volume formula that shows up on your formula chart is 1/3 big B times h, where big B is the area of the base. Now, if it's a cone, the base has to be a circle. So big B is really pi r squared times h divided by 3. So these are our formulas for cones. So let's try it out. The radius of my cone is 8 centimeters. I don't know my slant height, but I do know that my height is 15. Now, using the Pythagorean theorem, I can figure out what the slant height is. So 8 squared plus 15 squared equals L squared. 64 plus 225 equals L squared. 289 equals L squared. So the slant height is 17. Of course, that's because you take the square root there. All right, so the lateral surface area is represented by pi r L. So pi times the radius times 17. When I do 8 times 17, I'm going to get, let's see here, 8 times 17 is 136 pi. And we're going to leave that in terms of pi, centimeters squared. Next, we're going to do the total surface area, which is pi r L plus pi r squared. So this is 136 pi plus pi times 8 squared. So 136 pi plus 64 pi gives you 200 pi centimeters squared. All right, we can combine those because they both had pi's in them. Finally, volume, which is represented by pi r squared h divided by 3. So pi times 8 squared times 15 divided by 3. So 8 squared times 15 is 960 divided by 3 gives me 320 pi centimeters cubed. All right, I want you to try this one out. I want you to pause the video and see what you can do with it. And welcome back. So we have a cone, has a diameter of 32 centimeters and a slant height of 34 centimeters. The diameter is 32, so the radius will be half, so 16. The slant height is 34. So we need to use the Pythagorean theorem to figure out what the height of the cone is. 16 squared plus height squared equals 34 squared. So 256 plus height squared equals 1156. So we subtract 256 on both sides, so 8 squared equals 900. Square root that, so the height is 30. So it's important that you use the Pythagorean theorem on these cones. So lateral area is pi r L, so pi times 16 times 34. So really all we need to know is 16 times 34 there, and that is going to be 544 pi and centimeters squared. All right, let's find surface area. So pi r L plus pi r squared. So 544 pi plus pi times 16 squared. So 544 pi plus 256 pi is going to give me 800 pi centimeters squared. And finally, volume is pi r squared h divided by 3. So pi times 16 squared times 30 divided by 3 gives you 2560 pi centimeters cubed. All right, so hopefully you're able to get there with that. Now let's look at it working backwards. A cone has a lateral area of 60 pi centimeters squared and a diameter of 12 centimeters. So what is its volume? Well, it's giving me the lateral area, so let's start by writing LA equals pi RL. But LA is 60 pi, so 60 pi equals pi RL. Now we know the diameter is 12, so that means the radius has to equal 6. So 60 pi equals 6 pi times L. I'll divide both sides by pi first. Goes away. So 60 equals 6L. And divide both sides by 6. So L equals 10. So if you think of your cone, you know your radius. You don't know your height, but you do know your slant height. So the slant height is 10. The radius is 6. So using the Pythagorean theorem, 6 squared plus the height squared equals 10 squared. I get that the height is 8. So now let's plug into the volume formula. Pi r squared h divided by 3. So pi times 6 squared times 8 divided by 3, which is going to give us 96 pi centimeters cubed. Hopefully you're able to get there working backwards. All right, let's look at 2 more problems. I want you to pause the video and try if you can figure out this real-world example on your own. All right, so Sasha is making party hats for her birthday. She wants the hats to have a diameter of 4 inches and a slant height of 8 inches. So she wants the diameter across to be 4, so the radius would have to be 2. And the slant height she wants to be, well, it's a terrible cone, but 8 inches. Okay, that's what she wants for her slant height. Now, if we want to know the amount of paper she needs to use a party hat, we just need the lateral area. Because if you think of a party hat, you don't have a base to it. So the formula is pi RL, which we have. We have R, we have L. So pi times 2 times 8 gives you 16 pi inches squared. Now, she's going to make 12 hats. So we got to take this number and multiply it by 12. So we get 192 pi inches squared. That's what she needs for 12 different hats. Now, she's buying 12 by 12 paper. So how many sheets does she need? So we're actually going to have to take this now and multiply it by pi, because this is an application problem. So we get 603.186 square inches is what she needs. Now, if the paper is 12 by 12, the surface area of that paper is 144. So I do 603.186 divided by 144, and I get that she needs 4.188 pieces of paper, but that doesn't make sense to buy that much at a store, so she needs to buy 5 pieces of paper to make these cones. All right, so please practice your homework. Thank you for watching.